So I would never solve that question by substitution, even if you paid me. I would use elimination. I would never ask you to do that question by substitution. And those Algebra 2 teachers that ask you to do that kind of thing are crazy. There's no reason for that. I mean, it's set up for elimination. Why not just use elimination like we know how to do? You know? Oh, and by the way, I know you can do subtraction, but I don't trust your subtraction. Focus on addition. Make one of the variables opposites of each other so you can add the equations together, and then you won't make any mistakes. It's this whole, some of you get the, like to do subtraction, and then some things fall apart. All right, next slide. What? Okay, we'll figure it out. Well, I'm like, you can do that. Find the dimensions of a rectangular garden that has a perimeter of 100 feet. Now, perimeter, that's what? How do we find the...
You add the sides together.
You add the sides together. If we have 2 x's and 2 y's, and we add all the sides together, that's how we got 2x plus 2y. And they told me that we have 100 feet. The perimeter is 100 feet. They would like the area to be 300 square feet. We know that we do length times width for the area. This would be a good time for substitution. I know, you're asking, how do we do substitution? Why don't you take that second equation and solve for y? What do you get? 300 divided by x. Okay. How could we substitute that into the other equation? Put it in for y, thank you very much. Putting this thing in for y. So that means we got 2x plus 2 times 300 over x equals 100. Guess what, folks? This is probably a good time for graphing, as you can see on screen. Now, their graphing technique involved solving both equations for y. So they took this other equation and they solved it for y. What is wrong? Why is everybody like leaving? Okay, can't they just learn math? So if you solve that for y, what would you have? Solve that first equation for y so we know what they typed, what that black line represents. That's not what we're going to do, but... Yes, or 50 minus x. Right, because that whole, reduce the thing by 2 kind of thing, but that was correct. All right? You got gum in your hair? Okay. So that's how they ended up with that black line. All right? I, however, would see more value. Does this... Whoa, come on, move on me. Don't just put a yellow line on there. All right, can we simplify this part at all? Is it 600 over x, yes or no? Well, you can't just agree with yourself. I know that. Okay, you've got to find other people. Is that 600 over x? If you think it's 600 over 2x, wouldn't the 2 go into the 600 and make it 300 over x? That's not the same. We want 2 times 300 over x. It has to be that right there. That is. Right, because how do you write the integer 2 as a fraction? So we were multiplying the bottom by 1. If you multiply the top by 2 and the bottom by 2, what fraction did you just multiply by? 2 over 2, also known on the street as 1. How exciting is that? It's not. It's boring. Okay. So if I was going to graph this thing, I probably would personally graph this as one of the equations and this as the other equation, right? Well, the one on the right, that's pretty easy, right? That's a horizontal line. Are we going to come up with the same answers? We better. Let's try to graph it together. You got technology. You got technology. Let's try that zoom fit, see if it works. It's kind of ugly looking. I mean, it starts out looking, but it needs to be zoomed in. Yeah, we'll have to. We have another camera on. Some of you better focus. Yeah, 'cause we don't have a lot of time for this.
I'm not gonna lie, I'm not focused.
It does kind of look like a hyperbola. Nice. We do want to find when they intersect. Okay, so kind of hard to see the blue hyperbola and the red line. I'm guessing that it's over here somewhere is my intersection point. I think I need to lower the maximum y value a little bit. It looks like it's a little ridiculous. Let's see what it is. Holy cow! Okay, folks, if I make the high value 200, is that enough? If I make the high value 200, is that enough to see where these cross? Well, yep, I see them crossing right there, although this is still a horrible looking picture. So maybe I need to make the y minimum something more reasonable. How about 0? Man, that's nicer. Right? Okay. So when we go to calculate, what are we looking for? Intersection, thank you. Is the first one the blue one? Yes. Hit the enter button. Is the second, why did it not take it? Oh, it's still graphing? What is going on here? I hit enter. Is my calculator like malfunctioning? What's going on here? Oh, look at that. It's having a problem because it's on 0. And what's the y value? Really? Look.
Wait, I did something else.
It's not there, is it? So right now the calculator's struggling because it didn't have a coordinate. That was interesting. I didn't realize that. So now I can use the enter button. Is the second curve the other one? Yes. Hit the enter button. Do I need to guess? No. 6.97? Is that exactly what they found when they did it? It is. So, kind of two different methods to do this. You can either use the y equals 50 minus x and the y equals 300 over x and graph those, or do the substitution like we did and then graph it that way. You're still going to use the calculator to find the intersection point. I guess two different ways to handle it, whichever way you prefer. Still graphing. Okay, what are we going to do? Substitution is correct. Okay, it says solve the system. Then you can support it graphically, but you better show me the algebra. You know, there were a few of you that didn't do that on your test. You know, you had an answer but no work. Talk about sketchy. So if we substitute, what are we going to do? Move the negative 6x. I think we should move the 3x over. Probably. Yes, probably, as they say. Okay, which gives me what? Negative 9x. I shall suggest for you that you factor it. Go, factor it. I like the first step. After that, I can't agree with you. The last step is not correct. Now, it's not on the, not like horribly wrong, but it is wrong. I like your first move, but not the second. That is correct. All the way to the end. Now, tell me what the answer is. It's true. It's true. Yes, I like that first move, right? Won't be odds because it's a minus. That's the difference of perfect squares. That would only be true if it was a plus 9. Hopefully, you pulled out a GCF of X. Okay. That's true. At least for me. Yep. X minus 3, X plus 3. And my 3 answers are yes, yes, yes. If you need to graph it, you can graph it. You can check. You can do the intersection. There will be 3 different places where the cubic polynomial and the line cross. And they will cross at 0, 3, and negative 3. Stay focused. Cannot believe I'm recording this.
I'm sorry. That's why you could hear that across the room.
Like future kids might hear this video.
It's true. That is true.
Huh? It's okay. We're still learning. We're all good.
Okay. What do we want to get rid of? X or Y? Are we allowed to multiply each equation by a different number? Yes. Since we want them to be the same, opposites of each other, we'd have 6x plus 9y equals 5. Negative 6x. Yes, I'm just waiting to see if they'll catch it. So if I leave it 5, is it going to really mess me up? Okay. You got to catch those things. You can't multiply through part of the equation and not all of the equation. And those of you that do that end up getting really weird answers. I'm not saying all your answers are going to be integers. That was called Algebra 2. You ain't in it. But you do need to be careful. What do we got there? 52, 57? Dang it. It's a nice number. 57 over 19 is not a nice number? Is that 3? I guess. Well, let's say, how about 60 divided by 20? What's 60 divided by 20? That's 3, right? Well, what if you took 1 away from 20? That'd be 19, right? If you took 3 away from 60, that's 57. So in other words, you're taking one of the multiples away. That kind of idea. All right. So, Mr. Hess, which equation would you like me to plug the y back into to find the x? I think that's a great idea, personally. 2x plus 9 equals 5. Subtract the 9, 2x equals negative 4. X equals negative 2. Is the answer 3, comma, negative 2 or negative 2, comma, 3? Does it matter? Yeah, it's a different place in the universe, folks. So it matters. So we're walking into matrices, and we will keep going on the notes.